Okay, we are now on another example of Bernoulli differential equation, but we are on the standard form of Bernoulli in X. So Bernoulli in X, same process as what we've discussed in Bernoulli in Y. So Bernoulli in X have this standard form. So we have this standard form, dx over dy plus x py equals x raised to the power of n q of y. So again, the same process. We need to eliminate this one by dividing both sides. Okay, so we'll eliminate that one, dividing both sides. After that, you will have this standard form. After that, this variable with a power 1 raised to the power of n, which is x raised to the power of 1 minus n, becomes your u. So, sa ato ang Bernoulli in y, that we name it as m. So here, we just name it as u so that we are not confused if that is Bernoulli in x or Bernoulli in y. So if you are fun with using your m, so you're free to use variable m. So from here, because maybe you will have confusion. So you have derived this one. So again, you'll need to derive this one. After that, deriving that one, you can now make sure that you can have a value the same as this to be equated. So after that, you can now get your, so substitute, then simplify it, cancel this one, multiply it here and here. Now you could get your PTY, QTY, because you already get your PTY, now you could get your integrating factor, which is e raised to the power of integral of PTY dy, because we are now in Bernoulli in X. That's why that is PTY dy. So you will clearly look at it that you will be using PTY because what you get here is all values or variable of y. So obviously you will use dy. Okay? So if you have x here, then you use dx. Okay? It just mean that you are using Bernoulli in, if this is y, Bernoulli in x. If this is x, Bernoulli in y. Okay? Then same general solution. Okay? The different is the variable. So let's try this example. Okay. So let's try another example. Let's use our paint. So let me clear. Okay. Let me enlarge our paint. Sorry. Okay. I think that's only what we could get. So now let's try to look at our given, which is dx over dy. So we have to write this one. So sorry, we have brush, change the size, color is black. Okay. So our given is dx over dy plus x times 3, or let's say you have 3x here, equals 4x raised to the power of 4 times e raised to the power of 9y. E raised to the power of 9y. So we have e here. 4x. Okay, now let's try to solve this one. So from here, so we know that this one is not linear differential equation. This is Bernoulli D E differential equation in x, because that is dx. We have x here. But the problem here is if x is x raised to the power 4 is not here, then we could say this is linear, okay, linear differential equation. So from here, because we have two different variable in your Q, so this we need to use Bernoulli differential equation. So what will we do? So divide both sides with that variable. Don't include the number so that you will not have a hard time. So this one first, x raised to the power 4, this is the one that we need to eliminate. So x raised to the power of 4. So after that, where's my cursor? Where's my cursor? Okay. So from there, dividing that one, so therefore you have dx, sorry, we have, okay, where's the cursor? We have dx over dy all over x raised to the power 4 plus 3x over x raised to the power 4 equals 4x raised to the power 4 e raised to the power 9y over x raised to the power 4. So we'll cancel this one and this one. We could simplify this one. We could simplify this one and cancel this one. So after that, we could now transpose it to the upper part. So you have x raised to the power of negative 4 dx over dy, sorry, dy plus you have 3 over x cubed, right? X over x raised to the power 4, that is x cubed, equals 4 e9y. After that, we need to get our our m or our u. So from here, we could now rewrite this one. Plus, we have our x raised to the power of negative 3 times 3. Because this one will be our m and the other one will be our ptx later on, or this one still px. So we have 4e raised to the power of 9y. So from there, we get this one. So as I've written, that is u. So let's just follow u. If you want to use m, then use m. U is equal to x raised to the power of negative 3. So we need to derive that one. So du over dx, dy, because here that is already dy. So equals, you have to derive x raised to the power of 3 over dy, which gives you du over dy equals, derive that one, you have negative 3x negative 3 minus 1. That is how you derive in differential calculus, right? Dx over dy, because that is over dy. So this, when you derive this one, you always have dx. So from there, you have du over dy is equivalent to negative 3 x raised to the power of negative 4 dx over dy. So from there, if you could see, you have already this one, which our target to substitute. So from here we have, say this is our 1. So from there, we have our, transfer this one to the other side. So nakay du over dy over negative 3. So what remains here is x raised to the power of negative 4 dx over dy. So let's just name this one as our 2. So if you could see, we can now we have this form. We can this equivalent. We can substitute it here. Okay. So now let's substitute. So substitute 2 to 1. So our 1 is this one, which substituted with this one. So you have du over dy over negative 3 plus, copy this one, 3 over x cubed equals 4e9y. Okay? So from there, we need to make this one as only du over dy. So we divide both sides by negative 3. So now dividing both sides negative 3, so therefore you will have du over dy equals, so divide this one, that is not divide, sorry, that is multiply. So let's, because we cannot delete this one if we divide, so we need to multiply. So we need to multiply here. So now multiply by negative 3. So therefore, negative 3 times negative 3 divided by negative 3, that is 1. So now let's still use positive. So negative 3 times negative 3, that is negative 9 over x cubed equals negative 12 e raised to the power 9y. So after that, we could, hopefully it fits. If not, we'll delete to the other side. So after that, we will have to have du over dy plus, raise this one up. So we have x raised to the power of negative 3, or yeah, then your negative 9, because this will stand as our ptx or pty, is equivalent to negative 12, sorry, negative 12 p9y. Okay. So after that, let me make this one smaller. Negative 12. Okay. Negative 9y. So after this, we can now identify our p ty, because we have y, we have x here. So that is negative 9. Our qtx, which is negative 12 e9y, and our we can now solve for our integrating factor, which is e raised to the power of pty dy, which is equivalent to e raised to the power, what is pty, that is negative 9 dy. Now we will solve this one. So e raised to the power of negative 9 move outside dy. So therefore you have e negative 9 integral of dy, that is y. So we have an integrating factor which has the value of this. So let's have this. Okay. And this one. So after that, we will now substitute it to our general solution, which is u times integrating factor is equivalent to q dy times integrating factor dy plus c. Okay, so just substitute this one and this one.